Howdy calculates, ready to start chapter 3? I know I am. So before we start talking about what's going to be our main topic in chapter 3, which is maximums and minimums, I wanted to just refresh your memory on what they look like on a graph. So if you look at the graph that I created in the upper left with the blue, you'll notice that I have some relative maximums and relative minimums, because if I ask you for the absolute max, of course it keeps going forever, so there really isn't one. And if I ask you for the absolute min, of course it keeps going, so there isn't one. So relative maximums would be the peaks, and of course those would be at B or D. And relative mins would be at the valleys, and of course those would be at A and C. Versus the graph that I have on the green, since now the arrows are both pointing down, I actually have an absolute max at A, and I have a relative max at C, so still have a relative on this one, and then I have a relative min at B. And that's just to refresh your memory. I'm sure that you remembered that, and so you're going, oh yeah, I remember all of that. Okay, so moving on to the new terms. Extreme value theorem says, again, if I have, all important, a continuous function on some closed interval, then there has to be both a minimum and a maximum on that interval. So I'm going to explain that more as we go. And then, of course, relative extrema says that there's some point where, within that particular domain, see if I have domain somewhere here. Nope. So I'm just going to write it in. So within a particular domain, I'll be able to find some point that is the highest and some point that is the lowest. So if I specify a domain, you can find the relative max and the relative min. And then last but not least, for definition of critical number, and hopefully you learned this last year in pre-calculus, is talking about, and if I go back up to my graphs at the top, if I draw the tangents at any of those points and I look at the slopes, I get a tangent slope that is 0. Or it could be undefined in the case of points of inflection. And we're going to look at those. Of course, that'll show up on a cubic. And so if I have that slope either being 0 or undefined, then I call that x coordinate a critical number of my graph. And one thing you want to note is that C cannot be either a whole or an asymptote. And we're going to look at two ways that we can have critical numbers, and they are either at smooth maximums or minimums, and that's of course where my derivative is 0, my slope is 0, or a sharp max or a min, and that's where my derivative or my slope is undefined. Whoops, I didn't mean to put 0 in there. I meant to put C. Oopsies. Okay, so I've created some examples for you. Of course, here's one where when I draw it in, I get the slope is 0. And another example would be if, oops, that was horrible. If I get a cusp, because if I draw in the tangent, it's actually vertical, so that's where I get f of c, f prime of c is undefined. If I have a point of inflection, like on a cubic, I'll get a vertical, so also f prime of c is undefined. And if I'm graphing absolute value, where that vertex is, again, I'll have f prime of c is undefined. So those are all examples of where critical points occur on my graphs.